Hello everyone, welcome to lab today. Minerals. Minerals is the topic of study for us. We're going to go through and look at some mineral examples and just how we tell one mineral apart from one another. So I have in front of you the lab setup, and I'm going to put the camera here so that you can see what I'm doing a little bit closer and look at some of these mineral samples. So Minerals Lab starts now. Okay, so here we are with our lab setup today. You can see the mineral samples in front of you. The 6 known mineral samples, we know the names to these mineral samples for part 1. And then part 2 is going to go through some of the diagnostic physical properties that we examined in part 1 with these first 6 minerals. And finally then, the unknown minerals for part 3 are given on the bottom part of the sheet here, and you're going to identify these on your own. So we'll start with these. The minerals you see here for part 1 are in jumbled order. I do list the names of those: talc, hematite, quartz, gypsum, pyroxene, and calcite, not in that order. And what I'm going to do is take you through how to determine the physical properties of these minerals, and then how to actually use a flow chart to find what mineral each of them are. Okay, so we begin with luster. Luster is the ability for a mineral to reflect light. And in this top 6 minerals here, we have a variety of lusters that we're going to go through. So we're going to start with sample 1. This is sample 2, 3, 4, 5, and 6. Sample 1 is a good example of a mineral that has a glassy luster. Okay, so you can see it's glassy because as I move it around, you can see that the lights above are reflecting off of it. So that is a glassy luster. So under luster, you're going to write glassy. The next one here, sample 2, also is a glassy luster. Again, you can see the sheen of the lights with a glassy luster. Even though it looks a little white and opaque in some locations, you always want to see if you have any kind of shine to it, and this one certainly does. So that is also a glassy luster. And the next one, you guessed it, glassy. The next one, glassy. Okay, if you don't get glassy luster by now, there's something wrong with you. Just kidding, there's nothing wrong with you. You're a great student. Okay, you can see here now, this is a different sort of mineral, not glassy. You can see that it is metallic. It looks like metal, so we call that metallic. Okay, anything that looks like metal is going to be a metallic luster. Okay, now there are many minerals that look like metal out there, and typically minerals are either metallic or non-metallic, and if they're non-metallic, then they can either be glassy like we've seen, or they can be pearly. Here is an example of a pearly luster. It's got a little bit of a pearly sheen, and I'm not sure if you can pick that up from the camera angle here, but this is a pearly luster, kind of just looks like pearls, really. And that's characteristic of some types of minerals. So this is non-metallic pearly. And again, luster is the ability for a mineral to reflect light. You'll note that when I turn you loose to do the unknown samples, that you'll have glassy lusters, you'll see metallic lusters. You're even going to see a new one that I haven't described called earthy. And it basically looks like a piece of dirt. You can probably already guess which one that is just by looking at them, but that is luster, how a mineral reflects light. Moving on to the next mineral physical property, and that is hardness, how hard a mineral is. This is actually a pretty good diagnostic property because the internal makeup of a mineral is really determines how hard the mineral is. Some minerals have an internal chemical structure that allows them to break easy or to be crumbled easy. So those have a hardness that is lower on the scale, versus some chemical compositions put together minerals in a very compact way that make them very hard. Now, there was this German scientist by the name of Mohs, And he had basically a big mineral tournament, and he took each mineral and tried to scratch each mineral against one another. And the minerals that were very easily scratched, he put on the lower end of the scale, and the minerals that were easily not as easily scratched, at the higher end. And he basically took 10. He made that scale from 1 to 10, the hardness scale from 1 to 10. He took a mineral, a diagnostic mineral at each level, and assigned it a number to help us out. So, for example, 1 on the Mohs hardness scale is talc, and 10 on the Mohs hardness scale is diamond. That means there's no mineral softer than talc, and there's no mineral that's harder than diamond. Many other minerals are in between, but that's generally how it works. For our purposes today, we're going to either do soft, medium, or hard. All right. Now, there are fancy mineral testing kits to really nail down what the number of hardness is, but we're just going to, like I said, soft, medium, or hard. As it turns out, your fingernails are about 2.5 on the Mohs hardness scale. So I'm going to try to scratch these minerals today with my fingernails, and if my fingernails gouges into it, I know that this mineral is soft. Okay. Likewise, on the Mohs hardness scale, a glass plate is about a 5.5. So anything that grinds into the glass is going to be a 5, going to be considered hard. We'll call it hard today. And anything between my fingernail and the glass is going to be considered medium. All right, so as you can see, this glass plate has seen better days, but it'll still do the purpose. The idea is to try to get the mineral to grind into the glass. All right, we're going to start with, I guess we could start with this sample number 1 here. I'm going to try to grind my fingernail into the mineral. And what I find is that as I go after the mineral with my fingernail glides. It does not grind into this mineral. So this mineral is at least medium, if not hard. All right, next test is to do a glass plate. And what I'm going to do is take this mineral and I'm going to try to grind it into the glass plate. And if it grinds into the glass plate, then it is hard. As it turns out, this mineral is powdering up on the glass plate, so it is softer than the glass plate. So this mineral, harder than my fingernail, softer than glass, this mineral would be considered medium. So sample number 1, you're going to write M for medium, or you can write the word medium for hardness. Okay, sample number 2, fingernail glides, and it's hard telling if this, let me just try this again here. Yes, it is grinding into the glass. So this mineral grinding into the glass, harder than glass, hard. Sample number 2, hard. Okay. Next, sample 3. I'm going to try my fingernail and whoa, look at that. Look what my fingernail did to this mineral. That sample is definitely soft. This one, fingernail glides. Seems pretty hard. Probably heard that grind into the glass. That mineral is hard. Okay. Sample number 5. Yep, grinding into the glass. Some of it powered up, but it also did grind, so we're going to call that one hard. And sample number 6. Ooh, boy, oh boy, look at this. Watch this. I can actually powder that. I can scratch that mineral off. That is super soft. So that is hardness. Harder than your fingernail is medium. Harder than a glass plate, hard. Okay, softer than your fingernail, soft. Pretty straightforward. And I'm going to show you those demonstrations of each of these unknowns today when we get to that part. Next is cleavage, and this is how a mineral breaks. When something cleaves, it breaks, and so we're going to look for how many directions of breakage each of these minerals has. We'll start off with sample number 1, and you can see that there's a regular pattern to sample number 1. Can you see that? Sample number 1 is kind of like a box that's been smushed this way, right? That somebody took and smushed like this. Okay. If you're unfamiliar with that shape, it's called a rhombus. And you can look on the very, if we can get this, I don't know if we can focus in on this, but the corners of this are very regularly broken. You can see the pattern of breakage in this mineral. So this is actually what we would call 3 directions of breakage, okay? So for cleavage, I'm going to write down 3 for the number of cleavage directions, 3. It is actually rhombic in nature. This next one here is clearly has kind of a smooth side to it. So what does break regularly, but there's really difficult to tell what kind of, there's really no pattern here to the breakage. So when it does reflect light like glass, but it is not patterned, it's representative of 2 directions of cleavage. And sometimes you'll see columns or kind of like stair steps on these 2 directional cleavage things. This particular mineral, and again, I'm lamenting how difficult it is for you guys to see some of the stuff from my camera views here without the aid of a magnifying glass, but this is actually thick sheets. You can see that there are thick layers or thick sheets that make up this mineral, and they kind of like column out here and break down, but the main thing is that this mineral is in sheets. Okay, so that would be 1 direction of cleavage. All right, I also want to show you, just to give you an idea, there's another mineral here that I can show you that's not part of our stuff today, but this is thin sheets. It breaks up into thin sheets. You can see it flaking off here. This is the mineral muscovite. There's another mineral biotite that is also thin sheets. This one here is just random. There's no pattern to it. We would call this 0 directions. There's no real pattern. It's called either 0 directions or fractured. Okay, so that is the number of breakage areas, 0. This one also looks random. However, when you look very closely at it, you will see that there are little flakes. You might be able to see the sparkles. This is really a sparkly mineral. I wish you could see this in person. It's great. But this mineral has little pieces of sparkle, okay? And they are actually flat. So this is actually 1 direction of cleavage, okay? 1 direction of cleavage. So we're going to write that in here for the pattern of breakage, 1 direction. It could also be considered fractured. So let me just take a quick look. So we're going to put 1/0, okay, for that one. And then finally, this one, again, very hard to see, but this is the one I could really dig into with my fingernails. I don't know if you can see that in there, but there are layers, nice thin layers of mineral in there. So this one is actually also 1 direction of breakage or 1 direction of cleavage. So cleavage, the tendency for a mineral to break, and we went through and kind of listed these. When you diagnose your minerals, you're going to look at their lusters, you're going to look at the hardness, and you're going to look at the number of cleavage directions. And that's going to help you figure out what type or what rock type or what mineral you're going to have. The last one here is color, the last diagnostic property, and it turns out that a lot of minerals that are completely different are the same color. These two, for example, are pretty kind of see-through and very similar in their color. This one as well, you can see it's kind of clear or transparent. So color is actually not a very good diagnostic property of minerals, because you can see here I have several that are about the same color. So it is helpful, but not as helpful. So we'll just go through and write these in real quick. We would consider sample number 1 and sample number 3 clear, so we're going to write that in for those. Sample number 2 is white. Sample number 4 we're going to call pink. Sample 5 is silver. Sample 6, white. And so forth. So you're going to go through and identify the color for your minerals as well. The physical property that I'd like to talk to you about is called streak, and this is the powdered color, the color of the powdered version of the mineral. And so actually, I'm just going to have you add the streak color right off to the side out here. We're just going to write in streak. Okay, and we'll get the streak color or the powder color for each of these minerals. Sample number 1, white. Sample number 2, white. Sample number 3, white. Sample number 4, white. And sample number 5, this mineral is gray, but the streak turned out dark reddish brown. Let me try that again.
If you need your yearbook picture taken, yearbook only pictures, they are outside, down to the right from the main office, towards Stevens Street. You'll see the photographer.
And sample number 5. That's interesting. Sample number 5 is a silvery color, but it gave me a reddish brown streak. Okay. The advantage of doing a streak color is that sometimes the powdered version of the mineral looks different than the actual mineral. So that usually comes into play when you talk about metallic minerals, but we want to do the streak color for everything, the last streak color being white. But it is a useful diagnostic property for minerals. Now that we have all of our mineral physical properties, we're going to find the mineral name. And the best way to do that is to take all the diagnostic properties that we find and try to use those to help identify the mineral. To help us today, we have a handy-dandy mineral identification flowchart. And this one has on it all of our physical properties that we tested, and including some special properties there. And then finally, it has categories for each so that we can narrow down what the mineral is. Okay, and so we're going to do that so I can demonstrate how this works. We'll start with the first mineral. Okay, the first mineral right here, this mineral we found to be a glassy mineral with a medium hardness, cleavage 3 directions, and a clear or transparent color. So we come to our handy-dandy mineral flow chart, and our luster was non-metallic glassy. This was medium hardness, so it could be any one of these minerals here. Okay, and it turns out that the streak color was colorless, so it's going to be one of these. Okay, we narrowed it down to 3 minerals. It's either calcite, halite, or fluorite. And remember that rhombohedron I talked about? It has rhombs. So we think that this mineral is calcite. Now, interestingly enough, calcite reacts with hydrochloric acid. So let's do that test just to make sure. I'm going to be confident and write down calcite here. But I'm going to confirm with this test. There is no other mineral that fizzes with hydrochloric acid. And this is about the strength of, like, I don't know, a soda. Okay. But no other mineral fizzes with hydrochloric acid. So let's try this out here. Confirmed. This is indeed calcite. Okay, looking at the next mineral here, it is glassy, it's hard, it has 2 directions of cleavage, and it has a white streak color, perhaps even colorless. So we come to the luster, and the luster is the first thing, white, and, the luster being glassy, brings us down to the second section here, or the third section down. It is hard, so that narrows our mineral down to just 4 minerals. It's one of these. It has 2 directions, so that could either be pyroxene, orthoclase, or plagioclase. And it is white in color, so I think we're looking at plagioclase here for this mineral. This mineral is plagioclase. Hard, colorless streak with 2 directions of cleavage, a white color, plagioclase. This is a type of mineral that you would find in granite. A lot of the white flecks in granite countertops are plagioclase. a lot of the pink color in granite is orthoclase, the cousin of plagioclase, just a potassium-rich feldspar. Okay, next mineral here. This one we said was glassy. It's soft, one direction, and has kind of a clear, translucent color. Come to our handy-dandy chart here. The luster, again, is non-metallic, glassy. The soft mineral, you come over here, thick sheets. There's only one that's soft with thick sheets on our chart, and that is gypsum. And that is indeed gypsum. Gypsum is what they use in like drywall. They crush this up, and they use it to make drywall. So this is what you would find in there. It's a calcium sulfate mineral that crushes up and works nicely there. The next mineral, sample 4, was glassy, pink, hard, 0 directions of cleavage. Again, we come down to our glassy section here, noting that a hard mineral with 0 directions of cleavage, fractured, it says varies in color. This actually can be, it's quartz. You can have, this is rose quartz, but you can have milky quartz, smoky quartz, green quartz, purple quartz. So it comes in a variety of colors based on the different chemical elements that mix in with the silica. So we have a little piece of rose quartz, a very light rose. You can hardly see it on the camera there. So that is quartz for number 4. Number 5 was metallic. It was hard, 1 direction of cleavage with a silver color. We noted that it has a red-brown streak. So we're going to go to our metallic section this time, noting that hard brings us to 2 mineral types, either magnetite or hematite. And the red-brown streak is our diagnostic property here. The red-brown streak is actually, when hematite weathers, it turns reddish-brown and kind of dirty looking, like a old rusty piece of dirt. Okay, so this is hematite. So we're going to write that in for sample number 5. And finally, sample number 6, a pearly mineral with a soft hardness, 1 direction of cleavage in white. So we're going to come down to non-metallic earthy pearly here, and that's the middle section for luster. It is soft and white. It is in sheets. It's talc. So that does it. We've come up with the mineral names for each of the minerals based on their physical properties. We've completed section 1, and you can use the information we just obtained to complete section 2. Part 2 of the lab asks you to look at the different qualifications of each of these minerals in the known minerals above and answer the questions below. All right, we move on to part 3, and in part 3, I'm having you identify some unknown minerals. We're going to do the best we can here remotely. So here we go. I'm going to show you each mineral and talk through the physical properties. You're going to identify what you think they are and write them down. And then you're going to use the flow chart to identify the mineral name, just like we did in part 1, only you're on your own for part 2. So here we go. Unknown number 1. Unknown number 1, first of all, is what's its luster? Is it glassy, earthy, pearly, or metallic? Also then, how about its hardness? Its hardness, my fingernail glides. It also glides on the glass. So it's between my fingernail and glass plate. Okay. It is a white streak color. White streak color. And breakage directions, cleavage directions, how many? Well, it looks like it's a cube. It looks like it's cubic. And then finally, special properties. I will tell you that this one tastes like salt. All right? So go through and write down the physical properties I just discussed, and then go ahead and identify what mineral this is. Next mineral, unknown number 2. Unknown number 2 is it glassy, earthy, pearly, or metallic? Next, the streak color, or actually, sorry, hardness. My fingernail glides, but this thing actually glides on the glass. So again, medium hardness. How about the cleavage? Does this look familiar? Is this one direction, flat sheets? Is it two directions, very difficult to see? Or is it three directions where you actually see cubes or rhombohedrons? Okay, that would be cleavage. So write down how many directions you think. The streak color is gray. And you'll need to find the mineral name for that one. That's a pretty mineral. It's very heavy. It has a high specific gravity, very heavy. Unknown number 3. Unknown number 3 is obviously golden color. It is kind of has a high specific gravity. It has a random breakage pattern. It is 0 directions of cleavage here. Its streak color is actually dark gray. So the powdered version of this mineral is dark gray. If it was gold, I would stop the camera and take it and cash it in. But the streak color, the powdered version is colored gray, or dark gray or black. And the hardness, let's test the hardness of this. Look a little difficult because it's bumpy, but my fingernail does glide on this. Some of my fingernail comes off on this. Let me take a look at the hardness here. It's actually gliding quite a bit. So I call this actually medium in hardness. Looks like gold, obviously, so that's unknown number 3. Unknown number 4, first thing I see about this, looks like a big piece of dirt, rusty dirt. So we're gonna say that unknown number 3, its luster is it glassy, pearly, earthy, or metallic? Hardness, oh, it's harder than my fingernail. And it's actually digging into the glass plate. So this is, some of it's coming off, but because it's so crumbly, but it actually digs in the glass plate, so it is hard. Let me see here. The streak color, reddish brown, actually very similar to, this is the reddish brown I just got. It's very similar to the other reddish brown we saw earlier in sample number 5. And looks rusty, definitely looks rusty. So you figure it out. And finally, sample unknown number 5. This one's very pretty, light green color, kind of translucent, very beautiful. Its luster then, is it glassy, earthy, pearly, or metallic? Hardness, fingernail glides. Yet it glides across the glass, so this is medium in hardness. This one is unique in its cleavage. What I actually see here are like pyramids or triangles for the cleavage directions. So I'm going to leave it to you to look at that flow chart. What cleavage direction shows pyramids or triangles? We actually did not talk about this when we talked about cleavage earlier, but you can kind of see the pyramids or triangles in here. Look at this triangular shape. And then there's another triangular shape here and another one here. Okay, so what shows pyramids or triangles with its cleavage direction? And then it's a very beautiful color, right? So this is actually the state mineral of Illinois. So you're going to identify that one. That's unknown number 5. So that ends the identification portion. You can rewind the video if you need to take a look at each of the different unknowns to see their physical properties and to write them down. And then use the mineral flow chart to find what the mineral name is. And that's pretty much it for the lab. Well, that's it for today. I hope it was helpful to take a look at some of these minerals and go through some of the physical properties that help us tell one apart from another. Please, as always, email me if you have questions. And thanks for joining me today. Have a good one.